The following video demonstrates how to quickly calculate simple stockpile volumes. It will use two different methods, so you can decide which approach works best depending on the data being modeled. The starting point is a model in n4ce, where each stockpile has been surveyed with a unique string number on each bottom of batter. The first method for determining the volumes of each stockpile that we will use is string volumes. In this mode, each base string is used to contain the volume of each stockpile. n4ce then uses that feature to determine a best fit plane running through each base to approximate the ground under each heap. If the edge strings do not all have unique string numbers, then they can be added or changed via the Recode option under the Lines tab. Each stockpile must have a unique string number, so it can be properly itemized in the report. Before we can calculate any volumes, we first need to create the DTM to give us an initial model of the mounds. Now we will select the string volumes option to start to calculate some quantities. In the bottom left of the view, n4ce prompts the user to pick line features. Click on each base feature in the order they should appear in the report. When all the stockpiles have been selected, right-click. With volumes in n4ce, the idea is that we are asking n4ce to calculate the volume to turn what is on the screen to whatever we are projecting to. With inclined plane selected, and when using string volumes, n4ce will best fit a different plane through each base feature. In the normal sense of cut and fill, because we are projecting to a plane through the base of each mound, we would expect the volume to report mostly as cut, i.e., we need to cut away the volume to get to the base plane. Currently, though, swap cut and fill is ticked, so the quantities would be reported as fill. For now, we will untick it so they are reported as cut. From the text report, we can see, as we would expect, large cut volumes. We do, however, see small fill volumes as well. This is because the bases of the stockpiles are not 100% flat. In other words, there will be places where the base strings dip below the best fit planes, resulting in small fill quantities. If these fill quantities were not small, then it would indicate that the ground under a particular stockpile cannot be modeled as an inclined plane. We would have no choice but to use the next method in this example for calculating volumes. We are not interested in the slope areas, so we will untick these for now. For completeness, and so anyone looking at these results will understand the units of the volumes, we will add them to the column headers. When tables are plotted, they are done relative to the current scale. If we want a larger table, one that is easier to read without zooming in as much, we need to increase the drawing scale and then repeat the string volume steps. The smaller table is no longer needed, so we can delete it. We now have a reasonably large table plotting the volumes in each stockpile. However, approximating each base to an inclined plane is not the most accurate method to use. If the mound is sitting on another stockpile or against the side of a bank, then we would need an accurate model of the ground under the stockpile to properly enclose the volume. To simulate that approach, we will create a new model, extract just the base strings, and model them separately. We will now use normal Prism volumes to calculate the exact quantities of the stockpiles. Clicking the Groups button takes us into the DTM Groups dialog box. Here, groups can be added to the current model, and then fill styles added to them. But to itemize them, we first need to group them. Groups are a way to essentially add triangles to a collection of other triangles that are then split up in area and volume reports. Group definitions need to be set up and can be saved for future use. In this project, we have 8 such groups ready to be assigned to some triangles. Fill styles again are user definable. Please only use solid or shaded patterns if you also need to export any drawings with groups to AutoCAD, as these are the only styles which are compatible. The groups have already been created for us in this project, so we can just use them. With Mound1 set as the current group, we will select Add Inside feature from the Groups tab. Then, click the Outer Boundary feature of the first mound. With the first mound grouped, we can change the current group to Mound 2 and repeat the process for the second stockpile. This is then repeated for the other groups until each mound is individually grouped. Now all the mounds are grouped, we can use the tool Delete, all ungrouped triangles under the DTM Edit tab to remove unwanted triangles. The point markers and the triangles are not really needed, so we will turn them off for clarity. So that each group can be clearly identified, we will use the Group Label tool to annotate them. To ensure text of the label is not too big, we will drop the scale down 1 notch. The text style for the label is set to a pre-existing style that has been set up with a size much larger than normal. This is so that the group names are easily large enough to read without having to zoom in. With the mounds now grouped and labeled, we need to create a second model, one that holds just the base data. We need to copy the base features from the mounds model into the base model. One way to do this is to right-click in the mounds model point list and choose Select Normal. Under the Code tab, we enter in the code we would like to search for, followed by an asterisk, so that all codes starting BB are identified in the search. Make sure no other tabs are enabled, otherwise their conditions will be included in the search criteria. Now that the appropriate points have been selected, we right-click and select the Copy option. Then changing over to the Empty Bases model, we right-click and choose Paste. When we view the model, we can see some additional lines and points coded BB, which should not be there. These need to be deleted before we can continue. With the erroneous points gone, we can now create a DTM of the bases. We do not necessarily have to delete the triangles between the bases because we have already deleted the intermediate triangles from the other model. Because there are no corresponding triangles in this model, there can be no volume between them. But we may as well delete the unnecessary triangles to keep the model looking neat and tidy. Using Delete Triangles via the one side of a feature tool, we can quickly remove the unwanted triangles. Back in the mounds model, we increase the scale once more so that we get a larger table. Now all we need to do is run Prism volumes using the default projected option. Pick the bases model as the surface to compare against. The text report that is shown now lists each group's quantity. Notice that each group has 0 fill because we are modeling each mound against its exact base. Finally, we will plot the simplest table with just the cut and fill values. If group labels are not ideal, then the group fills can also be added into the table of results. Placing the Prism volumes table next to the string volumes table allows us to compare the results of the two methods directly. For this example, our string volumes are within 1% of the actual Prism volumes, but this can only be the case where the base of a stockpile does sit on an approximate inclined plane of some kind. Where the ground under a stockpile is more complex, then extracting a base string before using Prism volumes is the best and most accurate method for calculating stockpile volumes. That completes this example on stockpile quantities.